We are on a private farm in the Bear Creek watershed in Hamilton County, Iowa. And this watershed has been the site of a long-term water quality monitoring project, or watershed management project, where we've been working with landowners for over 25 years to assist them in establishing conservation practices to improve water quality. So on a stream side or riparian buffer like we see here, for water that's moving off of that crop field through the buffer towards the stream, there's some really high performance rates for removal of sediment and nitrogen and phosphorus that are attached to that sediment. The other thing that we've demonstrated through a long-term series of groundwater monitoring that we've done with wells that stretch across the riparian buffer is that for that water that moves below the surface and moves through this buffer below this perennial vegetation, that there's significant removal of nitrogen in the form of nitrate nitrogen. And as the buffer ages, that nitrate removal gets better, it improves. Uphill, we're draining about 25 acres, and then that tile drain comes down and comes through this buffer and then enters Bear Creek behind me. Well, the challenge there is that for anything that is moving in that water, in that tile drain, it's moving through this buffer without any of the function of the buffer being able to remove or interact with any of those nutrients. So it essentially short circuits the function of that buffer. This buffer works well to remove nitrate if we can get that water into that soil. And so we thought, well, can we take that and move some of that tile water into this soil and then head it towards the stream? So that's where I'd like to give credit to my long-term colleague Dan Janes, who's with the U.S. Department of Agriculture, Agricultural Research Service in the National Lab for Ag and Environment here in Ames. He was the one who came up with the idea and said, hey, let's put in a structure, and intercept that tile, and then let's put other tile along the buffer, and then let's capture some of that water and then put gates within this structure and redirect that water out into that distribution line, and then within that, and then have it go through that soil towards the stream rather than going directly through the tile towards the stream. So here we have the control structure. As we come in, we have the tile coming in into the top end of it, and then there's several chambers, and we have control gates within here, and we set those control gates so that we put a little head on it, and that forces the water, rather than going towards the stream, it heads into the distribution lines. So this is the outflow tile from the tile that drains the 25 acres and then goes through the saturated buffer. But one of the things you should notice is that there's no flow here, but there is flow into that control box, which means that 100% of the water that was coming from that from the tile drainage is moving into that distribution line and into the saturated buffer. So this was the site of the very, very first saturated buffer that we established in 2010. Initial funding was supported by the Leopold Center for Sustainable Agriculture and the USDA ARS. We established this with a line that goes about 1,000 feet upstream and about 100 feet downstream. And so then the way we monitor performance on that is that we measure water quality here at this structure. And then we have a series of wells that extend from that distribution line towards the stream, and we measure the water quality within that well. If we have nitrate concentrations 10 to 15 parts per million milligrams per liter within this distribution line, as we monitor that water as it goes towards the stream, by the time it nears the stream, almost all of that nitrate nitrogen is removed at this site. So they work very well. We wanted then, after the first really positive results, one of the things we wanted to do was say, hey, well, let's expand this. How well does this work in other locations with other ratios of watershed area to buffer area? So that's where the Iowa Nutrient Research Center has been very important. They allowed us to work with Water Quality Project and project coordinators across the north central part of the state, and we established a series of these within those water quality projects. So we now have, through the support of the center, we now have about 20 of these sites that stretch from Buena Vista County up towards near Oelwein, Iowa. We've seen that there is differences in how well they work, but they all do work well.